Let's take a look at this problem. We got f of x is equal to x over x minus 1. And first thing we want to find is f of 3. Well, evaluating the function is always the same. You go to the original function. Everywhere you have an x, you put in a set of parentheses. Everything else remains exactly the same. The fraction is still there, and the minus 1 is still there down below. Now, whatever's inside the parentheses right here is automatically going to put in here and here. So put 3 there, 3 there. Now here we got 3 minus 1, which gives us 2. So our answer is 3/2. Our second one is f of negative 1. And again, this is just evaluating a function, so we'll go back to our original function. Everywhere we have an x, we'll put in a set of parentheses. Everything else remains exactly as is. Now whatever's inside the parentheses here is automatically we're going to put in here and here. So put a negative 1 there, negative 1 there. So we got negative 1 over negative 1 gives us negative 2. And remember, if you have a negative divided by negative, it gives you a positive. So this becomes a positive 1/2. F of 3/2. Evaluating is always the same. We'll go back to our original function and replace our variable, the x, with a set of parentheses. So we got parentheses over parentheses minus 1. Now whatever's inside this parentheses automatically goes here and goes here. So put 3/2 here and 3/2 here. Now those parentheses aren't doing anything, so I can drop them. So we got 3/2 over 3/2 minus 1. This is called a complex fraction. Complex fraction is where you got a fraction inside of a fraction. And there's two ways to simplify a complex fraction. The method I like the best, because it works 100% of the time, is to multiply by the LCM of all the inner denominators. Now when I say inner denominator, we have fractions inside of the fraction. So here's an fraction inside the bigger fraction. So it's got its own inner denominator. Now this one down here has an inner denominator also. So we got two inner denominators, 2 and 2. The LCM of those is 2, since they're the same. So we're going to multiply everything by 2. So take 2 times 3/2 over 2 times 3/2, and then minus 2 times 1. When I say multiply by everything, I'm talking about what's separated by pluses, minuses, and the actual fraction symbol. So then this 2 cancels that 2. This 2 cancels that 2. And we end up with 3 up on top, and down below we have 3 minus 2 times 1 is 2. 3 minus 2 is 1, which ends up giving us 3. And that's our answer. Okay, next one is f of 4x. And again, evaluating a function is always the same. You go back to your original function and you replace your variable with parentheses. So I'm going to have parentheses over parentheses minus 1. Whatever's inside of parentheses right here is automatically what you put in here and here. So I'll put 4x in there, and I'll put 4x in here. So that gives us 4x over 4x minus 1. And that would be our answer. Let's see. Next one is 4 times f of x. This is not evaluating a function. What we're going to do here is you replace your f of x in our problem with whatever f of x equal. So we're going to put x over x minus 1 in where the f of x was. Now 4 times x is 4x over x minus 1. And that's our parentheses. That's our answer. Okay. So our next one is f of negative x. And again, evaluating the function's always the same. You replace your x with sets of parentheses. So we're going to have parentheses over parentheses minus 1. Now whatever's inside of parentheses right here is automatically what you put in here and here. So we'll put negative x there, and we'll put negative x there. Now those parentheses aren't doing anything, so I can drop them. That's negative x, and this is negative x minus 1. Now I notice on these, everything's negative. So if I were to think about what that negative represents, I could factor the negative out of the top, and that's like a negative 1. On the bottom, since they're, I can also factor out a negative 1. Since they're both negative, it becomes x plus 1. At that point, you see that the negative 1s will cancel, and we end up with x over x plus 1. So why in the world do the negative 1s cancel here and the x's don't cancel here? Everything has to be multiplication for you to be able to cancel in a fraction like this. Here we have negative 1 times x, and here we got negative 1 times the parentheses. That's why these negative 1s will cancel. I cannot cancel the x's here because there's a plus, there's addition here. So this would be our answer. Next one is f of x minus 4. I think. Yes. Okay. So it's always the same. Evaluating a function, you go to the original function, you put parentheses in everywhere you have an x. Now whatever's inside the parentheses right here is automatically what you put in here and here. So I'm going to put an x minus 4 there, and I'll put an x minus 4 there. So I'm going to end up with x minus 4 over negative 4, negative 1 gives us x minus 5. Previous problem I factored out a negative 1, but I'm not doing it here. What told me to do it in my previous problem is both of my first terms on top and on the bottom were negative. That's what made me think to factor out a negative. Here, these are both positive, our first terms on top and bottom. F of, what was that one? F of x minus 4, so we need f of x minus 4. Well, this is not evaluating a function. What we're going to do is replace our f of x here with whatever we set f of x equal to. So we got x over x minus 1 minus 4. Now I'm going to show two different ways of doing this. First way, if we're going to subtract fractions, they both should be fractions. So I can put the 4 over 1. You can always create a fraction by putting it over 1. Now we need to get a common denominator, and since this one is 1, our common denominator will be the other. So our common denominator is x minus 1. Now our first fraction already had the x minus 1, so that's good as is. But our second fraction, we had to multiply the bottom part by x minus 1 to get our common denominator, so we multiply the top part by x minus 1. So then we got x over x minus 1 minus 4 times x is 4x, 4 times negative 1 is negative 4 over x minus 1. And now that they have the same denominator, I can merge together the top parts. Keep it in mind, whenever you have a minus in front of your fraction, and you got multiple terms up on top, this is going to change the sign of all the terms up on top. So this becomes x minus 4x plus 4 over x minus 1. Well, combine like terms, x minus 4x is negative 3x plus 4 over x minus 1. Now notice that my first term here is negative. That might make me think to factor out a negative 1, but since my bottom term is not negative, then I won't bother with that. Because nothing would really cancel at that point. Okay, another way of looking at it. An easier way, I think. Although you may not see it this way, this is a mixed number form. So we're going to take the number to the side, the negative 4. We'll multiply it times our denominator. We'll add our numerator. And your denominator remains as is. So again, took the number out to the side, multiplied it times the denominator. I added the numerator, and your denominator stays as is. Well, negative 4 times x is negative 4x. Negative 4 times negative 1 is positive 4 plus x over x minus 1. Negative 4x plus x is negative 3x plus 4 over x minus 1. And you see we come up with the same answer as when we did it the other way. Okay, so our f of x is equal to x over x minus 1. And I guess we're looking at the last one now, f of the x squared. And again, evaluating the function is always the same. You go back to the original function. Everywhere you have an x, you put in parentheses. Whatever's inside this parentheses is automatically what you put here and here. So I'll put an x squared here and an x squared here. Now those parentheses aren't doing anything, so I'll have x squared over x squared minus 1. And that's our answer.